All right, going way out of order. We jump from chapter 3 to section 10.5. Our objective will be to solve equations and inequalities involving absolute value. Let's do a little bit of a warm-up here. Absolute value is something we should have heard of before. So our first question is, what is the absolute value of negative 8, Jakeem? Positive 8, that is correct. This one, I think whoever made this just typed it funny. I don't think we should have these little pieces down at the bottom there. I think we just want the absolute value bars. So the absolute value of what number is equal to 6? Jamal? Negative 6. Are there any other options? 6. So negative 6 or 6 would have an absolute value of 6. Absolute value is the distance between the graph of a number and the origin on a number line. So to fit in kind of an example in your margins or right below there, we can look at that example from the warm-ups. So we said that the absolute value of negative 6 is equal to 6. Okay, so on a number line, so if we go to negative 6 on this number line, 1, 2, 3, 4, 5, 6. Negative 6 is all the way down there. I did not space those out very well. The distance between the graph of that number, so if I put a point at negative 6, the distance between that and my origin, which is 0, is 6 units. So that's what absolute value means. But we could also go in the other direction. We could count 1, 2, 3, 4, 5, 6 in a positive direction. And so this distance here is also 6. So the absolute value of positive 6 is also equal to 6. So it's all about the distance from 0. Okay, distance from 0. That is what our absolute value is talking about. We have two methods to solve equations and inequalities. One of them is by graphing. The other is by writing the open sentence as a disjunction, which I know that second one probably doesn't mean a whole lot to you yet, but I'll show you what they're talking about. Basically, it means we write one problem as two different problems. We look at both of our options. So if you want to add a little note below that, what this means is that we're going to split one problem into two problems. That's what that means. So the best way to do this is just jump into some examples. These first ones are pretty easy. They're going to go by very quickly. When we split this into two problems, we first have to make sure that there's nothing around the absolute value bars except for the equal sign. Which on both of these, I hope it's pretty obvious. There's nothing outside those bars except the equal sign. We have to have that be the case before we try to split the problem up. So since there's nothing around it but the equal sign, we split it into two problems. The first problem, we rewrite it exactly the same, but without the absolute value bars. So we just write it as x equals 4. So to get our other equation that we set up, We still use whatever was in the bars. That doesn't change, so that's still an x. Equals, but whatever's on the other side of the equal sign from the bars becomes its opposite. So it becomes a -4. Notice that when we did this, we don't have bars anymore. When we split it up, we don't use the bars anymore. If you wrote bars around this x or that x, you need to erase them. Okay, then normally what we would do is solve it, meaning we would get x by itself, but what do we notice? It's already by itself, so there's nothing more for us to do. These are the two answers. Now, I don't know that you'll have any quite that easy on your homework, but they're just trying to get us warmed up. So both of these are possible answers. Number 2, we're going to do the same thing. Who can raise their hand and tell me what one of my equations will be? May. X equals 12. One of them stays the same, just without the bars. Natalie, what's the other one? X equals -12. We keep whatever was in the bars, so the x, but this time we set it equal to the opposite, so -12. Those are both our answers. We have to have both of them to fully get the problem correct. Alright, these ones look pretty similar for the most part to what we've been doing. So we're going to split it up. X equals, the absolute value of x equals 100. Ellie, what's one of my equations? X equals -100 is one of them. Can anyone else raise their hand and tell me the other one? Keon. X equals +100. So it doesn't matter to me which order you put them in, as long as you have them both there. Does anybody notice something different about number 4? It's set equal to a negative. So it says the absolute value of x is equal to -10. Does that sound weird to anyone? No? Well, it should. And hopefully from here on out it will sound weird to you. Absolute values can never be negative. Absolute values have to be positive. Absolute value is distance. Distance is positive. So if you see the bars all alone and it's set equal to a negative number, your answer is going to be that there is no solution. An absolute value cannot equal a negative number. Before you make that decision, you do have to make sure that the bars are all alone. Okay, if there's something outside the bars, we got to move that first before we make that decision. From here on out, the examples are a little bit more interesting, but we're still going to follow the same steps. We need the bars to be alone, so the only thing outside the bars should be an equal sign, and then we have to split it up. Can anybody new raise their hand and tell me what they think one of my equations should be? Jaquan? Y minus 2 equals 4. Good. One of them stays exactly the same, just without the bars. What about our other equation? Lexi? Very good. We drop the bars and we set it equal to the opposite. So instead of 4, it's a -4. Now on these ones, is our variable by itself now? No. What do we have to do? Add 2 to both sides. So this goes back to what we were doing in chapter 3. We split it up. Add 2 to both sides. On this one I get y equals 6. That's one of them. On the other one, what am I going to do to get y by itself? We're still adding 2. We gotta be careful. I heard someone say -6, and that is not going to cut it. -2. A lot of people get excited on absolute values and they think that it's going to be plus and minus the same number. But when we start solving equations, it does not work out that way. So these are both our answers. Y equals 6 or y equals -2. We got to have them both. All right, on number 6, we need to split this into 2 problems because the bars are alone. Somebody new, somebody I haven't talked to yet today. Natalie, are you raising your hand? Okay. R plus 4 equals 1. Good, that's one of my equations. Anybody else want to volunteer before I start picking on people? Ryan?
R plus 4 equals -1.
Good, R plus 4 equals -1. Hopefully we're getting the hang of how this works, our pattern of setting up these 2 equations. Now we have to solve both of them. How do we solve these? Subtract 4 from both sides. Alright, 1 minus 4 gives me -3. We use the same steps to solve the other equation. We still have to subtract 4 from both sides, but what do we get this time? -5. Very good. So those are both of our answers. Alright, on 7 and 8, they kind of step it up a notch. Still, our first step is going to be to make sure that the bars are alone and then split up our problem. Any new volunteers before I pick on people? Delaney, what's one of my equations going to be?
7 minus x equals 4.
Thank you. All right. Jalen, what would my other equation be?
7 minus x equals -4.
Wonderful. Then I have to solve these. These ones are a little bit trickier to solve. I'm trying to get this x by itself. Can anyone tell me what I should do, Keon? Do what? Very good. Subtract 7 from both sides. We cannot drop off that negative sign in front of the x, so this is still -x equals, what is 4 minus 7? -3. But I don't want -x, I want positive x. So positive x would equal what? +3. If we change the sign here, we change it over there. It's like dividing by a -1. Alright, that's half of my problem. I follow the same steps to get x by itself on the other half. But this time I've got -x equals, what's -4 minus 7? -11. But I don't want a -x, I want a positive x. So I want +11. On number 8, do we have any new volunteers to tell me what they split this into? I'm only seeing old volunteers. While I appreciate you, I want some new ones. Kion.
5 minus 8 equals 11.
Wonderful. Nevaeh, what was the other one?
5 minus x equals -11.
Very good. We gotta split them up into 2 problems. Then we work on getting our variable by itself in both of them. What do I have to do to get the variable by itself? Okay, first we subtract 5 from both sides. Be careful when you do this. This is still a -x equals, what's 11 minus 5? 6. But I don't want negative x, I want a positive x. So if I flip that sign, what do I have to do over here? Flip that sign so that it's a negative 6. Okay, we're going to follow the same steps on the other side, but know that we could get different numbers. So we still subtract 5 from both sides. Negative x equals, what's negative 11 minus 5? Negative 16. Remember, you got to either remember your rules for adding and subtracting integers or invest in a calculator. Alright, but we don't want negative x, we want positive x, so it would equal positive 16. There are both of our answers. Who can tell me what my equation should be on number 9? Got a few people I haven't heard from yet today still. I'll start picking on people. Tariana, what would be one of my equations for number 9?
5b divided by 5 equals 10b divided by 5.
You're giving me a little too much, but yes, you're correct. But for now, we're just setting up our equations. We'll get to solving them in just a moment. So 5b equals 10 would be one of them. Carl, what would another one be? Very good. Then Tariana started telling us that what we need to do to solve is to divide by 5, which I agree with that. So on the left, my first equation I set up, b equals 2. Alright, I follow the same steps on the other side, dividing by 5. This time b equals negative 2. So in this case, they did turn out to be opposites. So it can happen, it just won't always happen that way. Alright, on number 10. First, we're looking to split it up. Kelby, what would one of my equations be?
X over 7 equals 2.
Very good. Danielle, what would the other one be?
X over 7 equals
Wonderful. X over 7 equals negative 2. Alright, we're trying to get x by itself, so what are we going to do on this one?
by 7.
So multiplying by the reciprocal is kind of correct also if we think about it as a 1/7, which is true. Either way you think about it, we should be multiplying both sides by 7 over 1 or just 7. So on my first equation that I set up, I get x equals 14. Alright, I follow the same steps on the other side, and I get x equals negative 14. There we go. X is by itself. We have our two answers. On these problems down at the bottom, 11, 12, 13, 14, are the bars all alone on that side of the equal sign? No. There's stuff going on outside of my bars. I don't like that. I need to get rid of it. So we're going to do that just like we would if we were solving an equation. We still move stuff to the other side of the equal sign the same way. Jaquan, are you trying to tell me what to do? What am I going to do? Very good. My first objective is to get the bars alone. So in order to do that, I first subtract 4 from both sides. Be careful not to drop the minus sign in front of the bars. That stays there. What is 1 minus 4? Negative 3. Now, some people might be thinking, ding, 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 the bars are set equal to a negative. No solution. But, are the bars all alone? No. What's out in front of them? A negative. So I cannot decide that there's no solution just yet. I need to get rid of that negative. So just like when we were doing that with the variables, if I flip this to be a positive absolute value, what happens to the other side? It becomes a positive. Its sign changes also. If you change the one side sign, you got to change the other side sign. Now, what are we ready to do? Not quite divide. Because I don't have two equations. I gotta split it up, right? We needed to split it up so that we don't have bars anymore. Jeriel, what's going to be one of my equations when I split it up?
3y equals 3, and then going to take the other 2.
Oh, sure.
3y equals negative 3.
Beautiful. Got them both. Now what are we ready to do? Divide. Now we're ready to get y by itself, which means we are dividing both sides by 3. So on the first one, y equals 1. On the other one, we again divide by 3. This time we get y equals -1. Ta-da! All done. Okie dokie. On to number 12. Are the bars alone? No. What's going on outside the bars that we need to get rid of? The +3. We got to get rid of it. How do we get rid of a +3? Subtract 3. But if I do it to one side of the equal sign, I got to do it to the other side of the equal sign. Notice that I'm not doing it inside the bars, right? This is all one side of the equation. So just do it one time. People get excited sometimes and try to do it inside the bars and outside the bars and on the other side. Don't get excited about it. Just one time on each side. Good, for the 8 minus 3? Alright, so when we get the bars alone, we have 2 minus a equals 5. Something I did not mention yet, but I feel like is worth mentioning. When you write your absolute value bars, make sure you either make them really bold or you make them really tall so that you don't think that they're ones. Okay, that happens to people every year. If you write your bars a little too small, like some people would write it like this and then start thinking that that's a 12. Don't do it. Okay. Now, are the bars alone? Yes, so we are ready to split it up. We gotta split it up. Anybody new want to help me out? Houston, I don't think you've helped me out yet today. What's one of my equations? Wonderful. Logan, what's my other one going to be? Beautiful. Alright, we've got our two equations. Now we got to solve. How am I going to get a by itself? Subtract 2. That leaves me with negative a equals 3, but I don't want negative a. Good, we switch both of the signs. So instead of a negative a, it's a positive a. Instead of a positive 3, it's a negative 3. We follow the same steps on the other equation. But what is negative 5 minus 2? Negative 7, but I don't want negative a. I want positive a. A equals a positive 7. Alright, I saw most people do at least the very first step right. What was the very first step for this? Oop. Add 2 to both sides. The very first thing we did, or should have done, is add 2 to both sides. We need the absolute value bars to be totally alone before we split it up. So that gives us 3 times the absolute value of s equals 9. Now, are the bars alone yet? No. We are multiplying by 3 out in front. How are we going to undo that? Divide both sides by 3. So this gives us the absolute value of S equals 3. Now are the bars alone? Is there anything outside the bars but an equal sign? No. So the bars are alone. We split it up. This one turns out to be pretty easy here. What do we get? S equals 3. And S equals -3. Now, some people split it from here, where the bars weren't quite alone yet. And because there's nothing else inside the bars with the S, you probably got the right answer. If there had been like a +1 inside the bars with the S, it would have turned out differently. So, luck of the question. If you split it from the very beginning, you probably were able to get one side right, but you were not able to get the other half of it. Alright, on 14, we follow more or less the same kind of steps. Step 1. Add 1. 4, absolute value of P equals 16. And then, divide by 4. The absolute value of P equals 4. Then, split it up. I heard people say P equals 4. P equals -4. Alright. We are going to keep practicing these. You do have a worksheet for homework to keep practicing these. Make sure you get the bars alone.